is up? Daniel here with the Virtual Robotics Studio, and in this video we are going to assemble the fuel mechanism. You're going to need all of the shafts, wheel, intake, upper, etc., and the back hood that we made in the last video, and pretty much all of the other parts left in your black tote. So we're going to get started putting that fuel mechanism together, but before we do, we're going to give a special thanks to Argosy, First, Cross the Road Electronics, West Coast Products, Aramco, and Team 302, Lake Orion High School, for hosting our studio. First, before we start assembling, I did want to mention we ran into, on one of our intake rollers that we were making, where the 3/4 inch Schedule 40 PVC spacer was too big, and that fit on top of my 3D printed ones. So I did go and grab a piece of, so this is 1/2 inch Schedule 40 PVC, and made a new little 1/4 inch spacer out of that, and that fits a lot closer to the 3D printed one. So if you're watching this and you haven't made all of your spacers yet, or you're having trouble with the bigger size, don't get the pipe that says 3/4 inch on it, get the pipe that says 1/2 inch on it, and that's going to work out a little bit better. Now, if you made all your spacers out of the bigger 3/4 inch stuff, like we put in here, it's actually still going to work fine. I think the biggest problem for me was just that having the smaller 3D printed ones mixing with the bigger cut 3/4 inch PVC does not work. So that said, let's get started with our assembly. So the first thing we're going to look for is our 2 big aluminum plates. These are going to be kind of the basis for the whole thing that we're going to assemble. And just to orient ourselves correctly here, the flat side, so there's this flat edge here, that is going to be the front of the robot. So we're going to have both of these stacked like this. This would be the front of the robot, and they'll actually be standing up like this. So there we go. All right, so flat side is the front, and then this curved side is going to be back towards the middle of the robot. And when we work on these, we're going to need to make mirrors of each other. So I'm going to actually take them, stack them up, and then flip one over like this so that I know when I put all my bearings in, they're going to be on opposite sides. So we're going to eventually want the bearings on the outside of both of these plates. So again, when this goes up like this, I need all of my bearings to come in from the outside edges. All right, in the blue bag, there is a little tube with a bunch of bearings inside of it. That's what we need first for this step. And crack that open. So these are a bunch of hex bearings, and they are flanged, so it's going to fit our 1/2 inch hex, which is what we built everything out of. Or it would fit the churros, but I think none of the churros are going through these. And we have that flange on the edge, right? So we have that edge that's going to get caught. So when we push these in, they're going to go in, and then they're not going to, they're not going to go all the way through the holes. Okay, and we're basically going to take these flanged bearings, and we're going to put them on every hole on this plate where they fit. So these 2 holes are a little bit smaller, and you can actually see the bearing is not going to fit in those holes. And then this hole, of course, is giant, and all the other holes are for mounting stuff. So the middle size of the big holes is going to be exactly the size that the bearings are going to fit in. And for most of these, I've found that just kind of wiggling it, you can get it to go in without having to hit it with a hammer or anything. So that is what I would do first. It's obviously nicer if we don't have to beat on it. And we're just going to push it in. So all of these bearings will go from the same side, and we're going to get it 4 on each plate. So there are 4 of those holes that'll fit on each plate. If it is stuck and you can't get it to go in, and you need to tap on it gently as you can with a hammer, you do have to be careful too, because when these go in, right, they're going to pop out the other side. So you can't just have it flat on the table and hammer on it, because this is as far in as it'll go, and there will still be a pretty big gap around it. So if you do have to hammer it, you're going to need to get a couple of pieces of wood or aluminum that you can set kind of on either side like this to support it up in the air, and then you can tap on it so that that bottom has room to fall through. All right, but again, I think I did this on another set of plates already as well, and so far all of the bearings have gone in just by pushing them. Trying to keep it as straight as possible and just sort of like wiggling it, pushing the highest side in, gets it to drop in there nicely. All right, that looks good. Now, Next step is going to be to take these two plates. So the bearings are going to end up on the outside as we tip this up. So I have the flanges of the bearing on the outside here, and then the extra bit that's sticking out will be in the middle. And it's kind of like get this on a little bit of an angle. So the flat side here, that is going to be the front of the robot, and then the curved side is going to be the back. Okay, and what we're going to do is on the curved side, we're going to line up for the curved side. And on the bottom bearing on the curved side, so the lowest bearing kind of in the whole plate, we're looking at these ones down here, that is where we're going to put our one shaft that is different, that doesn't have the flap wheels on it. So this one that just has 5 3-inch spacers, that one goes into that bottom bearing. So let me take my temporary tape off, and I got to remember not to drop the spacers on the ground. So this is going to go into that bottom bearing, and it's going to go into the non-flanged side. So we'll slide that all the way in, and I'm actually going to like hold the bearing, because if I hold the plate and push on it, there's a really good chance I could pop the bearing out, which if you do is not a big deal. You just slide it back through and wiggle that bearing back into place. Okay, and you could potentially take your second plate on the other side and do the same thing. So we could take the second plate here and slide it into that other lower bearing. If you do it this way now, it's going to be impossible to put the other shafts in place without either popping bearings out or taking this plate back off. So you might find it easier if you're like working alone to do it that way so that the plate kind of stays in place for you. But especially if you have an extra set of hands, I think it's going to be easier if we don't put this second plate on yet. We'll leave that off on the side. And we put the rest of our shafts in first. So next up on the curved side, right, the next shaft up above where we put the first one in, we're going to take one of our shafts with those flap wheels in the middle. And so this one has kind of the 2 1/2-inch spacers as well on the inside. And we're going to take this one and same thing, slide it into that second bearing. And that kind of stays for me, but again, you're going to be much better off if you have a person that can help hold these in place as you get all 4 of them in. All right, next up, make sure that bottom bearing stays in. There we go. Get your other shaft with a flap, with the flaps in the middle. And this one is going to go on the next highest bearing. So now we're jumping to the flat side, and this is the one kind of all the way on the edge of the flat side here. I'm going to slide that one in next. Okay. And then I think at this point, I think if I tip this, got to be careful not to lose all of my spacers. I think if you put the flat side down, it's a little bit more stable when you put it in here. Okay, and I'm going to go ahead and I'm going to try to put my second plate in now before I put the 4th shaft in. You might want to put your wheels in, and I'll show you where those go in just a second, but I think this is all that I can have hanging off of my plates right now. So I'm going to get that bearing back in. I'm going to try to just be right on the edge on the other side of the bearings. So I'm going to slide this in until it's just on it a little bit to support it. Looks like my bottom bearing down here fell out. That's okay, I'll just put it back in. Let me take the tape off of that one. And we'll just get it started. Okay, and now if you take your wheels, so that wheel output shaft, that's going to go in the last bearing. And I'll see if it's far enough up that I can slide it in. It seems like not, so if I just kind of take that bearing that's down here, I can pop this bearing out, and then I can pass the shaft through, slide the bearing back on and in, and then we can go ahead and slide this one back into the bearing on the other side. And that is the way you could do all of the shafts this way, by removing the bearings and putting them back in. In fact, I have bearings falling out of this middle one too, so we'll just be putting everything back in as we go anyway, and that is fine. Okay, so our goal here now is to get all of the shafts in the bearings to all be in and to be kind of flat in against the spacers, so that we sort of have all of our spacing in and good. So just keep, when I push in, I'm pushing in on the bearings again just to try to, keep that good. The wheel, I'm going to just try to put it roughly in the middle. We're going to have other steps that are going to clean that up and make it better. So when everything is kind of close to in place like this, then we're ready for the hood. And the hood is going to be on the side here. We're looking for the holes up at the top. So there are 3 holes around the top edge. So we got one here, here, and here. And then the same holes exist on the other side. That is going to be where we go to line up our shooter hood. So it has those 3 different churro pieces that are going to align. And that is going to go right lined up with those 3 holes, and that's where we're going to screw it in. Now, remember the back hood here, as I take my temporary piece of tape off. This back hood here has a long side and a short side. And we need to make sure that we put this in facing the right direction. And I believe what we want is the short side to be facing up towards the wheels. So that's going to be on the top hole. And the long side will be reaching down towards this flap wheel here. And if we line this up on those holes, you're going to need your the same holes that we used to tap it before. So we have these 1/4-inch self-tapping, quarter 20 by 1 thread forming screws that we used to kind of get those threads set. And now you're going to see why it's so nice that we got the threads set. So if I line this up, I can just sort of hold it in place, and I can, because the threads are there, I can get all of these screws started and holding everything together. It would have been much, much harder to try to hold this all together while also drilling in or ratcheting wrench in to cut the threads at the same time. So I'm going to go ahead and get all of them kind of as far as I can go by hand, get them all started here. And they don't have to be super tight because it's going to hold together once we do that. And then we'll jump to the other side and get 3 screws in on the other side as well. And this is also going to help set our width. Once these are tightened in, that's going to make it so the bearings don't fall out constantly. So if you're struggling with those bearings popping out like I was, once this piece is attached, it gets a little bit more stable. So we'll get this one started. Okay, and then we got one more down here. All right, and now that they're all started, we know they all fit. They're in the hole that they're supposed to be in. So I'm going to grab a socket, and I'm just going to start tightening them down. And remember, you can hold the inside churro to keep it from spinning with a 1/2-inch wrench. Let's be on forwards here. There we go. Okay, and a word of warning, if you do use a power tool for this one, what I found when I tightened this all the way with the impact gun is it actually would tighten it and then twist the inside. It would have so much force that it would twist the inside churro a little bit. And if the churro is twisted between the 2 sides, that would make my entire mechanism not sit flat on the table. It would twist the whole mechanism a little bit. So even if you are going to use an impact for this, I would stop before it's all the way tight and do the last little bit of tightening with the socket. But I also think because we pre-formed all of the threads, it's not such a big deal to tighten it in with the socket all the way for this one. All right, so we get this one down and tight, and then move on to the last one here. Okay, that one's tight. Then we'll jump to the other side, and we're going to do the same thing. And I had a bearing fall out where I just slid it there. I'm not going to worry about that. I'm going to go ahead and get this in all the way tight, and then we'll fix the bearings. good. There goes another bearing, no problem. Okay. And the last one. And that's tight. All right. Now, I'm going to go ahead and re-pop in all of the bearings that I can get to here. So my bottom one popped out. I'll just push them all back in. Looks good, no problems. Okay. And then I'm going to tip this up again. So this is the proper orientation. This is the way it's going to be. And again, if your bearings are still falling out, don't worry about it. But the one thing I want you to check is if your bearings, like if you go to this shaft now, especially the ones by where we screwed the stuff in, if you go to that shaft and you push the bearings in all the way, if there's a huge gap, like if you can't even push the bearings into the plate, that might be a situation where we're going to have to take some of the spacers out and make them a little shorter. So if the spacers are so long that they're just going to pop the bearings out, we might have to deal with that. But we're going to wait before we make any adjustments until we're going to have one more churro piece that's going across and holding everything together. And then we're also going to mount this into the frame of the robot at the bottom. And both of those are going to also help control the width of the piece. So we're not going to worry too much about that until we have everything mounted. And we'll still be able to take the shafts out and work on them if we need to. All right. Next up is going to be the motors. So there are, if you look at where the wheel is, and we go kind of diagonally down from the wheel, there are these big holes with 4 mounting holes around the center large hole. And there's one of those on each side, because of course these are the same on both sides. That is where we're going to go to mount the motor. So we need to get 2 of our sim motors. And if you remember correctly, from a long time ago when we actually built this shaft, I said, hey, there is a small bag of fasteners inside the bag that those wheels were in. And now it is time for that small bag of fasteners. So from that bag, we're going to take out just the 4 bolts. So there are other pieces in here as well. So we have the 4 bolts. There are 2 keys and 2 of those retaining clips, just like we had on the chassis when we were doing the drive motors in the transmission. We're not going to get to those quite yet. We're going to save those for later. So we'll put the keys and the retaining clips back in the bag just so I don't lose them, but we do need the 4 bolts. All right, and then we're going to take one of the motors. And remember, these motors have 2 holes that are sort of fake. You can't mount to them, and 2 holes that are real that you can screw into. So you can sort of see there's something buried in those 2 holes. Well, let's take the motor over to where it's going to mount here. So if you put it from the inside, the extra motor shaft should be pointing out like this. And we can rotate it until it lines up with those mounting holes. But we have a couple choices. So let's see. Let me find them. Where are they? OK, so there is one option. And I'm going to just get this started so we can talk about it. It does help, too, sometimes if you pull the motor back so it's not flat against the plate, you can sort of see the hole that you're trying to get to line up. All right, so if we look at it on the motor now, basically the difference is we can mount it here, or we can mount it flipped around 180 degrees. If I flip this around 180 degrees, the only difference is going to be where these wires are coming out. So right now, the wires are coming out on the edge. So this is the front of the robot, and the wires are going up and forward. Alternatively, they could be down and back, but down and back is sort of like in the middle of the mechanism. That doesn't seem like the direction I would want them to run. Now, of course, even if the wires did go down and back, you could attach them to the motor and get over to the side of the frame and still be fine. You could make it work, but I think it's slightly better to have them pointing up and out on the frame, because then we can zip tie them eventually right to the motor, and then get outside the frame or along the frame or however we want to go to get it back into the rest of the robot. So that seems a little bit better to me, but it probably will work either way. All right, so since I'm happy with the way I randomly chose this motor, we're going to go ahead now and tighten these bolts in. And these have that nylon patch on them. So I think what I want to do is I want to grab the handled Allen wrench. That is going to speed this up considerably. Of course, if you don't have one, that's then just, take your time and go for it. But this seems much faster to me than having to take the Allen wrench out and put it back in every half turn. Oh, we lost some bearings. All right, oh. Should not have grabbed that shaft that just fell out. That's all right, we'll put it back in a second. That motor is in and tight. Let's get this bearing back in here. And then I got to put the whole shaft down here back through because I pulled it out. All right, that's all back together. Like I said, don't worry too much about it. They're going to fall out. It's just going to happen. All right, now we're looking at the other side. So we have this motor done. We have to do the same thing on our other plate here. So again, we have the center hole, and we've got the 4 smaller holes around it. I'm going to take our motor, and again, I'm going to start with the wires facing up and out, because that's roughly the direction I want it to be. Looks like I have, well, I guess I could mount it here, or I could mount it here. This one, the wires ended up kind of in a different spot. So, it doesn't really matter. In this case, I'm going to get my wires facing the same way as the other one. And that means I'm going to end up putting my bolts in not the side holes like I did on the first motor, but the top and bottom holes. And it really doesn't matter which holes you end up using, whether they're top and bottom or left and right. We get basically the same amount of strength either way, and nothing is going to interfere either way. All right, so we are here on the top and bottom instead, and that's going to be fine. I will hold the motor kind of in place, and let's tighten these down. That was another bearing falling out. No problem, though. Man, that screw is long. All right, first one's in. Second one, here we go. Okay, that is both motors mounted. I have the wires kind of in the same place. But again, really in any orientation you mount it, probably going to be fine. Let me once again pop the bearings back in. I'm only kind of popping the bearings back in because I don't want it to fall apart more. Really, I'm just worried about losing my spacers. That's the only thing that I'm actually concerned with right now. All right, So this is now ready for us to start working on the outsides where all of these shafts are out. We have to basically connect everything to our two motors. So one of the motors is going to control the wheel that launches, and I think the feed wheel as well. And then the other one is going to power the intake. The feed wheel in the back. The intake here in the front will be powered by the other motor. So we've got to get a bunch of our timing belt pulleys, gears, belts, and shaft collars ready to go. So I'm going to grab all of those pieces, bring them back over here to this table, get them kind of ready to use, and then we'll be back to get them assembled. All right, so we have all of our gears and pulleys ready to go now. I'm going to take our structure here, and I'm going to rotate it a little bit. And so this, again, flat side is the front. If I'm inside the robot, right, I'm standing on the curved side, so I'm inside the robot. On the left-hand side is where we're going to start working. So right now it's symmetrical. Actually, I bet you could do this on either side, and it would be the same. So if you do all of this on the wrong side, I think everything still works. You just have to know that your motors are going to be flipped when we go to wire stuff. But on the left-hand side is the side I'm looking at. And we're going to look for start at the motor. And next to the motor are two different shafts. One of them has the wheels connected to it. Not that one. That's not the one we want. The one below it that has the flapper wheel and those compliant wheels attached to it. That's the one we're looking for. And we're going to take our big gear. This is an 84 tooth 20 DP. And it is from WCP, West Coast Products. This has a hex-shaped hole in the middle. Couple things. One side is scooped out to save weight. The other side is like flat. There's a small raised bit in the center, but it's mostly flat. We're going to take the scooped out side, and that is going to go facing in towards the aluminum, and that's going to go onto that shaft that we were talking about with the flap wheel. All right, and then to stop this from falling off, we're going to do one of our shaft collars. So one of our hex shaft collars, make sure it's loose enough. And I'm going to be holding the shaft on the other side to be able to push on this without pushing all of the bearings out. And the bearings will probably fall out anyway. That's fine. Okay, and we want that to go in and touching. Now, if you look at your shaft, the amount that's sticking out on this side, counting the gear, and you look at the other side, and they still look like they're about the same. So I've got, without tipping it over here, right, still about the same amount of shaft. We went through and centered it, so if your shaft didn't shift, this should be fine. If it looks like it's still centered, then you can go ahead and tighten that set screw down, or the bolt down to tighten that shaft collar. It's always fine if you have to loosen this up later. So if you tighten it and you find out, oh, we don't have enough space on the other side, that's OK. You can always loosen it up and adjust anytime you need to. So I'm going to go ahead and get that tight. Go ahead and put the short end in here just so I can make sure it's tight. All right, that seems good. OK. So our next step then is we need a gear on the motor. So when the motor spins, it can power this gear to make that intake shaft spin. And that is going to be, we have a tiny bag. This is a 10-tooth steel spur gear, 20 DP, 12T center distance, 8mm key bore, also from West Coast Products. So this is the little gear we're looking for in this bag. And you can see we'll put it on here. We're going to have to take it off, but we're just going to put it on to test. So if you slide that on, you'll see that it will mesh together. The teeth will mesh together. You might have to rotate them a little bit to get that to go in. But now, spinning one will make the other one spin. So that is looking pretty good. All right. So of course, just like when we did the drivetrain transmissions, we need a key to go in the keyway here. And then we can use that retaining clip to keep everything from falling off the shaft. So that tiny little bag where we got our motor mount bolts, we had the key and the retaining clip. I'm going to take those out. Just one of them. I guess we'll save the other ones for the other side motor when we get to it. OK, and then let's get the key into the keyway of our motor here. So just above that big gear, we have that groove cut out in the motor. That's our keyway. We're going to go ahead and slide the key into it. And again, I like to try to put the, see if I can do this without blocking it with my fingers and without seeing what I'm doing. All right, so I like to put the corner in kind of like this, so it's sticking out a little bit. So if you just get the corner started, that's usually the best way to go about it. Then you can squeeze it down the rest of the way into that keyway. And on this one, our gear is pretty wide. You can see how far the gear goes out. You need to make sure the key doesn't go out past where the gear is going to be. So it should be towards the back of the keyway, not towards the end here. And if that goes in all the way for you, then you're good. You can line up the keyways and slide the gear on. If, like me, this isn't going, like I have the keyway kind of lined up and it just won't slide on, this probably didn't get pushed down far enough into the keyway on the motor. And that can happen. That's pretty common. You just need to get a pair of pliers, any kind of pliers. And what we're going to do is just, well, I got to rotate the shaft a little bit so I can get around it. And then we're just going to squeeze that down so it goes all the way into the keyway. And now we'll try again. When I slide this on, if I line the keys up, I have one more problem, which is I have to line the keyway up, and I might have to wiggle the bottom gear to get the teeth to mesh correctly. And now we can see that is connected, and now the motor shaft is also spinning. All right, but this can fall off really easily, so that's what the retaining clip is for. And once again, on this retaining clip, we talked about this with the transmission, but it's got this sort of smooth side, and then the open side, and then the direction that the teeth are facing matters. So remember that we want sort of the smooth round side to be facing in towards the motor. And we're going to have the other direction facing out. So we have this side where it's pretty smooth, and the teeth are sort of facing in. That direction is going to go in towards the motor. And then on the other side, right, you can sort of see a bit more openness and the teeth pointing up. That's going to be facing out. And to press these in, I'm going to use a 3/8 socket again. So I'm going to kind of hold this onto the socket and then line that up on the motor and do my best to sort of push and wiggle it in. All right, we are started, so that's good. It's definitely getting it started is the hardest part. And then just sort of wiggle it around like this. Find that works the best. And get the bottom in a little bit. There we go. All right, and when you're done, right, we're not trying to like hit this with a hammer and get it super tight. Again, if this gear here can wiggle back and forth just like a little bit like that, that's fine. That's what we want to see. We don't want to add any extra friction that we don't need. So that's looking good. All right, now we can go ahead and test it again. Right? Be careful if you're turning the big gear because your finger can get up into the gears and twisted and pinched. And you'd be surprised how easy it is for that to happen when you're spinning here if you just kind of don't let go in time. But if you spin, you can grab kind of where the flaps are on the middle of the wheel. So like over in this area you can grab, and that's good. So go ahead and spin that, and you want to watch and make sure that your gears still meshing together, still spinning nice and cleanly. And that looks and feels pretty good. All right, so that one is done. Next up, we have the two shafts in the back here that are kind of hard to see, but if I spin the whole thing around temporarily, I'm going to spin it back around when we get back to work here. But these two on the bottom, these two are going to get chained together. We want these two, or belted together. We want these two basically to spin in unison. So they'll both always be going on or forwards or on backwards or off at the same time. So let me spin it back around. All right. So those two are these two shafts down here in the bottom. And those two we're going to belt together with some timing belt pulleys and a very short timing belt. So we need the 24 tooth, 15 millimeter wide. Plastic pulley, WCP 1444. So there are 2 of these pulleys that we're going to use. And then there is a belt. This is going to be our 55 tooth, 15 millimeter wide belt, HTD 5 millimeters. And our goal is to put these pulleys on, these 2 shafts, and have the belt be on in between them. Now here's the tricky part, is if I go to put these on, right, like if I put both of these pulleys on first, it's going to be almost impossible now to get the belt to go on. So we kind of have to do either the belt and the pulleys at the same time, or we'll have to move the shaft a little bit out of the way in order for us to do it one at a time. So if you get the first one started just on the very edge of the shaft, in fact, I'm sticking, the shaft isn't even reaching the end of it. Then we're going to put the belt on it, and then we're going to put the other pulley in. And I don't think, it doesn't really matter which direction these pulleys go. It does look like there are little Torx bits, though, that help hold it together. So just in case, right, you might have to screw those screws back in. I'm going to have those screws facing out so we could work on them if we have to. I don't expect you're ever going to have to do that, but it seems like a little bit better orientation. So I have that basically hanging off the edge of the shaft. I'm going to put the belt on. I'm going to take my other one and get it also on the belt. Okay, and then we have to pull this one up until the belt is tight and rotate the other shaft until we can get it to line up and get it started. And once it's started on both, it actually gets a little bit easier if your bearing pops out on the bottom, which is what mine just did. Then you're going to have to work a little bit to pull that bearing back down in. But once it's started on both, then we're basically going to push them in together. So just a little bit on each one until they are all the way in and touching those bearings. Okay, and then my bearings fell out on the other side, so I'm going to put those back in as per usual. All right, and so now we can test too. When one of those shafts spins, it's going to make the other one spin. And then what that means is, like when we look at our rollers here, right, both of those rollers are going to spin together, which is what we want to see. Okay, and then the last thing, of course, is these pulleys. Nothing really stops them from falling back off. I mean, there is tension there, and they both have to move together. But in theory, right, like we were able to slide them on, they could eventually work themselves off and fall apart. So on the outsides of these 2 pulleys, we are going to add 2 more of our shaft collars. So let me get one of them loosened up a little bit. See if we can slide that on. And the orientation of the bolt doesn't really matter as long as you can get to it to tighten it down. And what I want to do here too is I want to make sure that everything is pushed in nice and tight on this, that there's no gaps between the collar and the pulley and the bearing. Okay, and that one is probably tight, but I'll give it one little tug that way as well. And then we'll do the same thing on the top one. I think I'll probably put it in the same orientation so I can loosen and tighten them at the same time. I don't think it matters too much which orientation this one is. So one of the big differences, this one will be running slower than the launcher wheel. So if you remember when we assembled the launcher shaft with the wheels on it, I was like, well, let's flip them around to balance this as much as possible. But these are going to be spinning slower than that, so it's less important. We also don't have a second one to put on the shaft to line it up. All right, that is this whole side finished, almost. We'll come back and do a little bit at the end. We're going to spin the whole thing around now. Okay, so before we were working on, if you were inside the robot, we were working on the left side. Now, if you're inside the robot, we're working on the right-hand side. All right, and first thing we're going to do is get our motor ready to use. In this case, the thing we want to put on the motor is this hybrid. It's got a gear, and then it's also got a timing belt pulley, all in one. And this is a fancy 3D printed part. This we are eventually going to want to put on that motor shaft. But it turns out, like, if we did this 3D printed plastic, and we cut a keyway in the plastic, the amount of space that the keyway would have to support the key would be very, very small. And in plastic, it's probably not strong enough to do that. So instead, we have the hex-shaped hole in the middle, and that's going to transfer the torque, but it's going to do it spread out over more area. So it's going to be less localized force and more force that's spread out. So that's going to help the 3D printed part survive better. But that means we need to do something on the motor shaft to make this fit. So there is, in a bag, an 8mm key to 1/2" rounded hex adapter. So this is WCP 0794. And it's just this little, the middle is a hole with a keyway in it. And then the outside is just 1/2" hex. And actually the edges are rounded just to make it go into things a little easier. And we will also need our last retaining clip and key. So we'll start just like we did on the other motor by putting the key into the motor. We can also check as we go to do that, right? Like if we slide this adapter on, it covers the entire keyway. So let me get that keyway on that side there. So this goes past the entire key. So when I slide this on, the entire keyway is hidden, which means it doesn't really matter where we put this key. As long as we get the key in, we're happy. So let's get a corner in somewhere and then fold it down and press it in. That one went in pretty easy. So I think I won't need the pliers, but they're here just in case. So I'll try to line up the keyways and slide that on, no problem. Okay, and then we are going to put the pulley on next. So we're going to slide our gear pulley onto that adapter. Make sure the gear is on the outside and the pulley part is facing in towards the robot. And now we have just a little bit of space left on the shaft, and that is just enough room for our retaining clip. So once again, make sure the teeth are pointing away from the shaft, and I'm going to use my 3/8 socket one more time to try to get that to go on there. And you do want to be a little careful because you're pushing hard, and it's really easy to bang your finger into the shaft that's below it. You could take that shaft out. You could also wear some gloves here. And we're going to push that in all the way. This one's interesting because it actually is going to hit the hex adapter that's on the inside instead of the gear. So even if I push it in as hard as possible, there will still be just a little bit of play in this gear back and forth, and that's perfect. That's what we want to see. All right, so that is good. Next step, just because it's going to be impossible to put the belt on if we don't do it now, we're going to get our other belt. This one is from ThriftyBot. It's 105 teeth, 525 millimeters long. It's a 5mm pitch and a 15mm wide belt. So we're using the same type of belts everywhere. But drop that around here onto the pulley on the inside. And the next step then is we're going to work on the wheel shaft above. And one of the things that we can do here with the wheel shaft is look to center it. So this one is still really free to slide all over the place. Oop. I'm going to try to line my wheels up so they're in the center of the whole thing before I do this next step. Now, that's also going to mean that the shaft is sticking out the same amount on both sides, so I'm going to check that. It looks about the same. Then you can go ahead and slide the other. This is an identical piece, gear and pulley. Now this one's interesting because we're not going to use the pulley side. We're only going to use the gear side. But it's easier to print two of the same part than to have a separate part that we're designing and printing. So slide that on, and the gear should mesh together with the one on the motor. And you can see that's going to spin our wheels. And one thing to note here, right, is I told you the wheels are going to go faster than everything else. So in this case, we have the same size gears on both sides, which means we're going to spin this shaft, which the wheels are attached to, at the same speed that the motor spins, which is 5,000 RPM, but it's going to slow down a little bit for friction or forces on it. So those wheels are going to spin very, very fast. All right, now nothing is stopping that from falling off. So it is, of course, time for another shaft collar. And this one, I mean, I guess with this one you could try to once again, adjust it to a different spot. So if I look at the collars in the middle, they're opposite each other. I'm going to make this one be rotated to a new direction from the other ones. And then when we put the same shaft collar on the other side, I'll make that shaft collar opposite to this one, just so they're all always having something going the opposite way. And I'm going to, once again, last step here is just make sure that shaft collar is in when the wheel is basically in the center. And it doesn't have to be perfect. We can always loosen the shaft collar on the wheels and move those around if we have to. But now I'm going to go ahead and tighten this one down. And one tug with the short side in. All right. Next up, we are going to take this belt, and you can see that it reaches this shaft down here. That is going to be where we want it to go. So we need to somehow we have one more pulley, 3D printed pulley. This one is a 32-tooth pulley from Stratasys, apparently made out of nylon. We're going to need to get this on the belt and on that shaft. There are two different ways that you can do this. I will show you what I think is the easiest way first, and then I'll show you an alternative way second. So right now, this shaft doesn't really move, but we know how easy it is to make the bearing fall out. So if I do push on this shaft, we can kind of make that bearing fall out. And it's going to be the bottom two shafts together, right? Because if I spin this around, remember, on this side, we have the belt between them. So both of those shafts have to move a little bit together. So I kind of popped out both of those bearings on that side. And now what I can do is put the pulley on the belt, pull it tight, try to line up the hexes here. And when the hexes are lined up, hard to see from across the table, but we should be able to get it to line up and slide in. Then we can just push that shaft back through and pop the bearings back in on the far side, and we're good to go. That, I think, might be the easiest way, but let me undo this, and I'll show you the other way. If your bearings and stuff don't come out easily, or everything is together and you don't want the bearings to pop out, there is one more trick you can use. So let me get the bearings back in on the other side first, if I can. There we go. All right. So now all our bearings are in. If you put the pulley on first, and you basically pull the belt as much as you can onto as much of the pulley as you can. We need to get the teeth to engage on one of the two sides. And it doesn't matter if you do the bottom or the top. But if you can get those teeth to start engaging, what I can do now is I can reach in and grab the shaft. And I'm going to turn the shaft, probably by grabbing the flapper pieces in the middle. That gives me kind of the best grip. But if I rotate the shaft, and I keep pulling with my finger too, my fingers are helping on the outside here, pushing in, keeping that belt engaged. If you turn it, you can usually get it to walk onto the pulley. You got to turn kind of hard, though. And we're almost there. You can see it's almost on, and just keep turning, and there it is. It popped on. So that way works as well. You can either do that walking and rotating to get it on, or you can pop the shaft out, align it, and then push the shaft back through. OK, so we can look at what's happening on this side really quickly. So the motor, 1-to-1, right, same size gear, is going to drive the main wheel, the main launching wheel. But then we have a small pulley on the back of this and a bigger pulley down here, which means we're slowing down the speed of the motor a little bit. So this shaft is going to be spinning slower than the motor shaft and this shaft. And you can kind of see that too. Like if you look at yours, if you spin the motor shaft, you can see this shaft, like visually, is just spinning slower in comparison. And that's good. That's what we wanted. We want our intake, our rollers and stuff to not be spinning like too crazy fast because we need some control. But we do still want to spin it fast, and this will do that. All right, next up, this pulley here can still fall off. There's nothing that stops this pulley from sliding in and out. So I'm going to push that all the way in against the bearing. And yet another shaft collar is going to go on. Slide that one all the way in until it's nice and tight. We want these to be squeezed in tight because they're going to help hold the structure together as well. And we'll tighten it. And if it's at some weird angle when you're tightening it, you can always rotate it to wherever you want it to be. Okay, tighten that down. And we're good. Okay. Now, most of our things are attached. Like all of our gears are powered, or all of our shafts are powered that we need to be powered. So we can follow through on this side, right? This motor is going to spin the launch wheels. And then we also know the belt is coming down to our upper. This is our feed roller, I think. And then on the other side, right, that feed roller that's powered by the belt on one side is now chained down and powering the belt on the other. So that means that when we spin this, the wheels spin, but it also makes both of these rollers on the bottom spin at the same time. All of those are connected together with one motor. And then our other one in the back, in the front, this is our main intake roller here. This one is powered just by this motor geared down to it. And so this one, we're slowing it down even more. So our first intake roller that's going to suck the ball in from the ground goes the slowest. And then we have our back two, which go a little bit faster, and then the wheel, which is going to launch it out, which spins really, really fast. But you might notice that as I'm playing with this, some of my shafts are still moving, and we want to stop that from happening. So on the side we were working on, we have two shafts left, one down here and one up here where I managed to pop the bearings out yet again, that have nothing stopping them from moving. So on both of those shafts, we're going to take a shaft collar. And I think I'm going to go this way because I can reach that one to tighten it. And we want this slid in all the way. So on the other side, like if we look all the way across the whole thing, we have the shaft on this side and here as well where that shaft collar is going in. I want to squeeze both of those in together until they're really tight and right up against the bearings. And then when they're right up against the bearings, then we can tighten this one down. Okay, that looks good. Then we need another one on this shaft down here on the front. And I'm going to do the same thing, right? So get that started. Push it all the way until it's tight. And now I'm pushing. Basically, there's a shaft collar already on the other side. I'm going to push those two shaft collars together as much as I can. So we're right against our spacers. And then we can tighten this one down. Good. And we have one more on the other side. So we'll spin it around. And it's the wheel shaft up here on the top that can still move. So we have that empty exposed shaft here. We're going to, this one I said I'm going to look at the way I put the shaft collar on this side. So this one, right now, I have the bolt on the top. So you can see that the bolt is right there on the top. And then I'm going to spin it around to the other side. And since the bolt is on the top for that one, I'm going to put the bolt on the bottom for this one. Just, you know, whatever. We're keeping that launcher wheel as balanced as we can. So now my bolt is on the bottom. Again, I'm going to squeeze both of the shaft collars together. Actually, this one you don't need to squeeze. This one you shouldn't squeeze because we don't have spacers on this one. So the idea here is we want to push it in until it's touching, but don't push harder after that, because you can bend the plate in, because there's nothing that's going to stop it from moving. So this one, just gently bringing it in until it is touching the bearing. And then that's it. Tighten it down. Actually, don't tighten this one down yet. Just get it ready to tighten down. Because if we pushed it in too far, we're going to have a hard time with our next step. So on the front of the robot, we have a few more holes in the front that we can use for stuff. And one of the things that we're going to use is we're going to put our churro piece going across the front. And you can see my churro does not fit inside the area. And likely that's because the first time I pushed that shaft collar in, I probably went a little too hard on it. So we're going to have to kind of bend that back just a little bit to get that lined up with the hole that we're going to use. And the hole that we're going to use is, it's going to be the closest one to the motor. So as we push this in, there are sort of like two holes here right above the motor. We're going to go down to the lower one to get that lined up. And then this, of course, is going to be the same thread forming screws that we used on all of our churros before. And once again, we did pre-tap these or pre-thread these in that preparation step. So that should hopefully make our life a little bit easier here if we can get it lined up. Yep. So it's going nice and easy. Get that one kind of as close as we can. All right, and then on the other side. And if you are still having trouble, like if yours is still really not lining up, try to open up your wheel shaft a little bit more and see if it goes. And if that still is too tight, then it's probably this one below, this flapper one that's below the motors. Go ahead and loosen up one of those shaft collars to open that one up as well. But for me, just the wheel one, I had squeezed too tight. Now I have plenty of room and it goes in really easily. So now on the other side here, we will start the screw in that bottom hole. And actually with this one, if you don't tighten either side, you can kind of hold on to the bolt, even if you do it with the socket itself. If you hold on to the bolt, you can spin the churro piece, and that usually is the fastest way to get it close. And then when it gets close, I will switch to 1/2-inch wrench here. And then we'll just tighten it down the rest of the way. So that side's tight. Spin it back around here. And 1/2-inch wrench and socket. And that one's tight. All right, now you can tell that plate doesn't have much flex at the top because that last churro is holding it together. So now, again, I don't want to squeeze, but I definitely want to bring this shaft collar back in until it's touching the bushing or the bearing there, and then tighten that last shaft collar in. Okay, we got a couple more pieces to attach, but before we do that, we want to align our entire, everything that can shift left or right, we want to align it so that it is close to the center as possible. And the easiest way to do this is we have these flap wheels here. Now, in my case, because I 3D printed these spacers, right? Like I know those spacers are equivalent lengths because, I mean, 3D printers, they do the same thing over and over again. So I know these flaps are in the middle of the robot. So what I'm going to do is I'm going to try to line this up like, and of course the camera's not going to be perfectly lined up, but I'm going to look at the wheels and see if my wheels are lined up. If the gap in the center of my wheels is lined up to the gap in the center of those flap pieces down there. And I think I'm off just a tiny bit. I think I'm a little bit shifted this way. So we can do this, we can fix this in a few different ways. I can either loosen the two shaft collars on the outside and slide everything over, or I can loosen the two shaft collars on the inside and slide everything over that little bit. I think what I like is we spent time measuring to get the outside shafts the same length. So I kind of like that it's centered like that. So I'm going to leave those ones alone, and instead I'm going to loosen up the ones on the wheels here. And then, you know, I'm just eyeballing it. It's kind of like if you put these two, the hood pieces, and you line the flap wheel up in the center of that, you can kind of see where it is. And I'm like very little off to the side here. Let's see, let me push that out of the way. There we go. And then bring it back in. Let's see how that looks. I went too far the other way. Like the tiniest bit more. And again, just like the last time I was trying to center stuff and I was taking all my time and measuring a lot, I'm probably being more precise here than I need to be. As long as it's about in the center, you're going to be OK. But I think that's going to be good enough. All right. So now that that's centered, I'm going to go ahead and tighten those set screws back down. Now, if your pieces are not 3D printed, which I recommend, it just makes the assembly so much easier. But if your pieces were all cut out of PVC and not 3D printed, then we center the wheel with a tape measure. And you can do this even if your things are 3D printed. But if you measure across the front here with a tape measure, from outside to outside, well, we're about 18 inches. It's about 18 inches. I think inside to inside, OK, so it's like a 16th under 18 maybe. Either way, if you kind of like look at it, the center of these two wheels should be at about 9 inches. And this is really close to the center. So that's the other way. If you don't trust your spacers, use this. You can do the same thing then if your flaps have to move a little bit. But in order to adjust the flap position, right, the only way you can do that is to go back through and cut some of them longer or shorter to move that position. The flaps can be off-center a little bit more and not cause too many problems. Then the other thing we want to make sure is in the center is the shooter hood back here. So that's these two rails that are coming up. And we can do it the same way. If you have the 3D printed stuff, you can rotate the flaps up and then sort of use those flaps to see if it's in the right position or not. I'm probably shifted slightly this way. I probably need to go the other way just a tiny bit. And we can do the same measuring thing as an alternative. So these are 2.5 inches wide because we have a 2-inch spacer, and then these are 1/4 of an inch each. So we have 18 inches. We should be seeing, let's see, so it's 18 minus 2.5 is 15.5. So to the inside edge here should be 15.5 divided by 2. 15.5 divided by 2 is 7 3/4. So if that line is on 7 3/4, that should be halfway. Mine is actually right on 7 3/4. Let's check the other direction. We should also see the same number. So that's how you kind of know. OK, that's just under. So I'm off center by less than a 1/16 of an inch. That is probably fine. But just so you can see the process, we'll go ahead and adjust it. So we're going to loosen up our two shaft collars that are here. And then try to slide it over by the amount, which in my case is less than a 1/16 of an inch. So that's about here. And then we slide everything. And when you're doing the second push, I'm going to keep my hand here so that this one doesn't slide farther when I push the other pieces over to match it. All right, and we can do another measurement to see. So that is now, for me, just over 7 3/4. And this one is just under 7 3/4. So I went too far. All right, let's push it back just a touch. That is almost exactly 7 3/4 again. And this is almost exact. They're both just a hair under 7 3/4. So I think that's going to be as good as we're going to do here. So now we can tighten these shaft collars back down so things don't move. All right, perfect. Okay, mechanically this is all together. And now what we're going to do is we are going to add a couple of our electronic components. So one of these holes at the top is going to be for our robot signal light. And then these 4 holes in the middle here are going to be to zip tie on our robot radio. So let me grab those pieces and some zip ties, and we'll get them mounted. OK, so you need the Vivid hosting box. This is the radio. It is a black box. And we'll open that one up first. Okay, so this is the radio. And we are going to attach this. One side has just 2 Ethernet ports. They're labeled DS and AUX1. The other side has 2 Ethernet ports that are labeled RIO and AUX2. And it also has 12V, so that's a voltage in with these extra connectors. The idea is when we put this on the robot, so our orientation, this is up. So when we put this on the robot, we want the RIO one, which is going to plug into the rest of the electrical system, to be facing down so the wire can nicely go down in the direction that it's facing and plug in. Also, the DS, if you plug your computer in directly to the robot instead of using wireless to test stuff, we call that tethering. You're going to be doing that in the pits because you're not allowed to use wireless connections in the pits. Well, the computer is going to plug into the DS port, so it's nice to have the DS port facing up where you can easily plug that in to your laptop, and the RIO facing down to get to your RoboRIO where it's going to connect. Also, if you do end up using the 12-volt ports, those also will be routing down to the rest of the power. So we're going to line this up. There are these 4 holes here on the side. We're going to line this up in the middle of those 4 holes, and we're going to run zip ties around it. If you look at the case, there are these little notches here and here. And those notches basically means if we get a zip tie in those notches, it's going to be pulled in by the zip tie being tight, but it won't be able to shift up and down because the zip tie will lock into those notches to hold it in place. So I'm going to take a zip tie. And again, we always like to think about, like, where do you want the bump to be? It probably does not matter, but the balls are going to move through, the fuel is going to move through the middle of the whole fuel mechanism. So I think the bump being on the outside is slightly better. So I'm going to feed this in from the outside, then pass it back from the middle. And you can actually start, depending on the length of your zip tie, you can get it started without having the thing in place. That makes it easier, especially if you don't have a second person holding stuff for you. But if you do have a second person, they can probably just hold it in place and you can tighten the first one down all the way. All right, and we'll get the second one going. Okay. Then we take the radio, remember power side and RIO down, DS facing up. And we'll just start tightening the zip ties down. Make sure they stay in those little grooves. And we'll pull it nice and tight. I think maybe I can get a couple more clicks out of that one. Yep. And then the bottom one as well. One of the things with zip ties is if you can make it so that, like if you see on the top, I made it so that when it's tight, it's right on the corner. That's going to be the tightest, because if the area you're doing is in the middle, you're going to have more of a gap here where air comes in. So it's nice if you can do that. Sometimes you try and it doesn't quite end up in the right spot, and that's OK too. All right, so there's the second one. And that is going nowhere, so that's really good. Also of note with this radio is that it does heat up quite a bit, so you want it mounted flush against the aluminum. We don't want to put anything in between. So later on, I'm going to mount a lot of pieces with Velcro to the robot. We do not want to do that with the radio because we need the aluminum part to act as a heat sink. And if we put the Velcro in between, that's going to act as an insulator. All right, get your flush cutters if you have them, and go ahead and snip these down nice and flat so nobody's going to scratch themselves. I did mention earlier that if you don't have flush cutters that you can melt the ends with a lighter. But with the radio right behind it, you got to either be very careful doing that or skip that step if you don't have nice cutters. All right, next, the hole above this is going to be for our robot signal light. This is going to be in an AB Allen Bradley box. from Rockwell Automation, I guess. But it'll look like this. This is what we're looking for. And first thing you want to do is there are some wires, or plugs for wires on the bottom with flathead screws. You can actually just pull that section out. And then there is a nut on the light that you're going to want to unscrew. So we unscrew this nut all the way. And then there is a little washer there. Make sure that doesn't fall off. Okay, so we can take this light now, slide it in through the hole. And then on the other side, we're going to tighten that nut on. And really, you can just kind of do it finger tight. That is more than tight enough. Okay, then on the inside, we're going to take our connector and plug that back in. Now, with this connector, the wires are going to come out the direction that it's facing. So there are, if I rotate it a little bit, so the wires are going to come out the bottom side. So the screws screw down on the wires, but the bottom edge here, that's the slots where the wires are going to go in. So when we plug this in, it really doesn't matter which way it's facing. The wires are going to be sticking out into the mechanism, so we're going to have to just bend those back around no matter what. So you don't have to really worry about even what orientation that ends up lined up. All right, that is it. That is a complete fuel mechanism. So we have one last step in this video, which is let's go ahead and get this mounted to the chassis of the robot. Okay, and the last thing that we're going to do before we get the chassis in here and mount it to the frame is we have two metal gears here on this side. So this is doing that front feed roller. And usually when you have metal gears like this, we talked about this when we were making the transmission, it's nice if there is some grease on those gears. Now, this gear, when it starts to spin really fast, is going to fling some grease. So we're going to go light on the grease, but I think it still helps to put some on there. So I have the leftover red and tacky grease from the transmission, and that's going to be a really good grease for this because it's so sticky. It does a good job of staying in place. So what we're going to do is we're just going to squeeze that grease out and rotate the wheel around. And I'm going to go light on it if I can. So we just keep squeezing some out. I'm kind of using the plastic to brush it on as we go. And just keep going until we get all the way around. That it? I think that's all the way around. All right, and then I'm gonna wipe my fingers off a little bit. I'm gonna spin that one around a bunch of times. Where do I want to spin it from? Spinning it from the roller is probably easier than from the outside. And that looks good. If you have a lot of grease sort of piling up on this one, just because I know when this starts spinning at the fast speed that it's going to spin later, like if you have a lot of excess, you could run it through with a rag just to wipe some of it off. So we can see it sort of made that one extra line of grease. We'll take a little bit off here. Then go ahead and spin it through again. Yeah, that looks good. Basically, you can see everything is coated and shiny, but there's not huge globs left. Because any huge globs are just going to make a mess. On the other transmission, right, that was inside of a plastic housing. So any extra grease when it starts spinning up to speed is going to get thrown against the outside of the housing. And that doesn't affect anything. It just kind of chills in there. This stuff is going to get thrown. Maybe it ends up on the radio. Maybe it just ends up all over the place where you are. So keeping this one a little bit lighter is better. But I think the grease will help, especially over the course of the season. And because this one is exposed, you might keep an eye on that. There is a chance that at some point during the season, the grease will have gotten worn off or wiped off or thrown off. And you might want to add a little bit more. But honestly, probably runs fine without the grease. It's just going to be a little bit better this way. All right, we do have the gears on the other side as well. But typically, when your gears are nylon, they don't need grease. The nylon is actually pretty low coefficient of friction with itself. So I'm not going to bother adding anything to that side. All right, last step. We're going to kind of get some of this cleared away, bring the robot chassis in, and we're going to get this whole fuel mechanism mounted in the robot. OK, we have the robot back, and now we are ready to mount our fuel assembly, our fuel mechanism into it. I think I've been mentioning that the flat side is the front of the robot. That's not true. The flat side is the direction that the fuel is going to get shot out. But we were talking about that side with the split. The opening here is the front of the robot. And actually, it's the curved side of this mechanism that's going to be facing forward there. So this should fit perfectly inside of our two inside frame rails and rest down like this. So we have that bare roller without the flappers on it is going to be on the very front edge, and that's going to grab the fuel and pull it in. And then the other rollers are either going to feed it back into the hopper or up to our launching wheels here at the top. So this is the position that we need it to be in. If we look at, let me pop this out for a second. If we look at the side of this plate here, we have 4 holes along the bottom. Okay, and then if we look at our frame, let me set this down, hard to do both things at once. So if we look on our frame here, I guess we'll look at this side. We have 4 holes kind of running across the top. So there's like 3 big holes in a row here, but then next to that, right along the top edge, are 4 3/16 holes. 1, 2, 3, 4. And those 4 holes are what we are going to attach the 4 holes on the fuel mechanism to. So let's see. I think it was pretty successful for me doing this on its side. So let's see if we can get that orientation to work again here. You might be best served by having one person holding it and lining up the holes while another person tries to come in to attach everything together. But we'll see if we can get this to sit nicely. This might be too heavy. All right, I think I'm going to have to tip it back down. So it's too heavy, it's falling out. All right, so we'll just drop it back in where it is sitting here. Okay, and you see, we'll work on this side here first. And we're going to continue using, so this is the same 1/2-inch button head 1032 bolts that we used when we mounted the ramp, that we mounted the pieces in the ramp. That's kind of our go-to bolt size, and the nylock nuts. And then you need the 5/32 hex key or Allen wrench and a 3/8 wrench. And once again, I think I like the idea of putting the nuts in the wheel channel here and the bolts in from the middle. So I'm going to go ahead and try to line up some of these holes and bolts. And I think if I can push all 4 bolts in, that's going to help hold it in place for me. So we'll try to do that. It is definitely harder to reach inside here with the floor in place. Okay, so those are all in. Let's see if we can. Okay. And then let's go ahead and see if we can get you know what, now let me go ahead and put the 4 bolts on the other side too, the same way. And then I think just the weight of it on the bolts might let me tip it up so I can get better access to where we're going. So you're going to have to push it around to get it to line up. Okay, so we're going to have to move this to get the holes to line up and reach down in there. There we go. Okay, with those two started, let's see if I can get, oh, it's really hard to reach the nuts in this angle. Let's try to tip it up now and see if it stays together. And this might be easiest for you as well. If you tip it up here, especially if you have somebody that's kind of still holding on to stuff, that might work out. So we'll go ahead and flip this up on its side. All right, we lost a couple of the bolts, but not all of them. So let's see if we can get these ones started. If we can get these ones started, then the whole thing will not fall apart on us. There we go. Okay, got that one started. Now I'll go for the ones that fell out and try to put those ones back in. I will say too, I'm holding it in this orientation. I don't want to let this tip down and rest on the fuel mechanism. It feels like it's flexing too much when I do that. So definitely have somebody that's holding onto it and keeping it from tipping down onto the fuel mechanism. Or find something to prop it up so it stays in place. But let's see if we can get these other bolts back in here. There goes one more. Let's get the nuts started on that. Okay, and then the last one. I think it's easier to reach in from the top here. Okay, that's through. Now it's unthrough. Okay. I got to go back around. All right, now we got it. Okay, get that nut in there. Okay, and then what we can do is get the hex key in here and on them. Oh, wait. All right, let me. Nope, that's going to tip. All right, I got to get the other size hex key. So let me go ahead and set this down for a second. We need a 1/8 inch hex key because these are button heads, not socket heads. All right. And we'll tip it back up so we can see what we're doing. Okay. So I'm going to get the hex key in there. And then we've got the 3/8 wrench. Okay, and I'm gonna, again, stop just before it's all the way tight, just to make sure we can get all the bolts in on the other side. Right now we only have 2 bolts started on the other side. wonder if the ratchet side, yeah, it doesn't quite fit. This is also probably significantly easier for you if you have a second person holding the robot up while you do this, because I'm trying to hold the Allen wrench and the robot with my left hand here. Okay, that one's close. All right, next one. Oops. Allen wrench fell out, there we go. Now we got it. All right. Okay, that one's close but not tight. Last one. All right, and that one is close. Now we're gonna flip it over to the other side. Move these cups out of the way so I don't hit them. What? Oh, I didn't put nuts on these yet. Okay, well, you know. So it goes. All right. Let's get a nut started on the one bolt that didn't fall out. And now let's go ahead and add more. So again, you'll have to shift the fuel mechanism around to get the bolt holes to line up. Whoops, shouldn't have moved. Okay, so we'll get this one started. And then try to get the middle hole here. There we go. That one started. Okay, and then there's one more hole to go. Perfect. And that one started. All right, now, these ones, we're just going to tighten them all the way down as we go here. Again, I don't want it to stop sliding. Okay. All right, there we go. I don't want it to tip back onto the fuel mechanism if I can help it, so now we can just start tightening this down. And this one will go all the way. So it is now tight. And we'll move on to the next one here. And we'll take this one all the way tight. Yeah, your life will probably be much, much better if you have a slim socket that will fit onto those, so you don't have to do all of this turn and reset. And 75%. There we go. Oh no, 75% for this side. We still have to finish the other side up too. And that one's tight. All right. Gonna tip it down again. And get the screw that I dropped to fall out. All right, and then let's do a little experiment. So we have the 4 bolts on this side that are still loose. I suspect we won't be able to get the camera to show it very nicely, but if you take your frame off the edge of the table, my guess is if you have one person on the front holding the Allen wrench in, I think you can reach up this way pretty easily. To tighten those in. Yeah, so I feel like this is probably the easier way for you to do it than to try to tip it up and have a second person holding onto stuff. And again, like I'm reaching through the whole robot and stretching my arms out. If you have one person holding the Allen wrench and one person doing the wrench on the outside, that also probably works a lot better than what I'm trying to do. There we go. All right, and that one is tight. Okay. Let's get this back up on the table proper. And we can kind of do a quick check here if we grab one of our fuel balls. So if I tip this back so it's on the back wheels, we can see that on the wheels especially, it does grab. And if we spin this, that is going to do a pretty good job of pulling the ball into the robot. Now, we get to that dead zone noodle, and you can see if that noodle wasn't there, this might sit too far down and not be able to go in the rest of the way. And then if we spin our other gear here, or other shaft here, in theory, that will pull it inside the robot, which it is doing. But also, if we spin this the other direction, that will feed the ball up into the wheel, which can then launch it out the robot. Gonna have to spin a lot faster than that, but everything seems to be in a good spot and working. So that is the end of this video. We have our fuel mechanism mounted to the robot and completely mechanically functional. Next video, we're gonna come back. We're gonna finally get those wheels reattached to the chassis and a couple of other loose ends to finish up the mechanical portion of the build. So we'll see you in the next video, but before we go, we're gonna give a special thanks to Argosy. First, Cross the Road Electronics, West Coast Products, Aramco, and Team 302, Lake Orion High School for hosting our studio.